Okay, so make sure you have your worksheet handy. If I show you this, it actually ends up being backwards, so I don't want to hold it up. But make sure you have it handy so that you know spelling because you're looking at it while you're taking notes. So in this lecture, what I'm going to do is talk about the limbic system. And the limbic system seems to sort of protect and surround the brainstem. So where the brainstem is the medulla and the pons and then the cerebellum stuck behind it, that's highly protected. It has all of the cerebral cortex around it. It's got our neck, and it's got our neck muscles. It's got some skull back here. So that's highly protected. And then part of that protection is this limbic system. And the limbic system is comprised of the hippocampus, which would be like my arms, like hugging it. My fists would represent the amygdala. The hypothalamus comes over the top. And then the cingulate cortex is sort of also sort of over the top. And then the thalamus would sit right on top of it. So you'd have the medulla, the pons, kind of like that, and then you have the midbrain, and then you've got the thalamus right above it, and then you have the cingulate cortex with the hypothalamus kind of coming down right here. And it's hard to see in this picture. So if we're looking at the whole brain like this, and the cerebellum keeps falling off, so it's just, don't worry about it, it's still here. But the hippocampus comes out around, and it's deep in the temporal lobe. So the amygdala would come out around like this, and then the amygdala would be out here. So it's like here's the right-hand side, and here's the left-hand side. So it comes out deep into the temporal lobe. And then if we open it up and look this way, here's the midbrain. I didn't mention it in the last video, but it's the structure right above the pons and below the thalamus. And it's below the thalamus this way. So then the structures that you can see here are, this in blue represents part of the thalamus, and then the hypothalamus is right down here in front of it. So thalamus, hypothalamus, and hypo means below. So like we have hypodermic needles. I would prefer that we had hyperdermic needles. You can think about that and tell me why it's funny on Monday. At least I think it's funny. So thalamus, and then right above the thalamus, I'm just going to list things because the corpus callosum isn't part of the limbic system. But right above the thalamus, there's a corpus callosum. And then this gyrus, which is like one of those worms that you see, one of the folds. This gyrus in yellow is called the cingulate gyrus, and it's C-I-N-G. And cingulate in this context means a belt or a girdle. And so it seems to be like the girdle holding all that stuff below it in. So that's the cingulate gyrus. So again, the limbic system would be the hippocampus and the amygdala, which would be tucked out in here. Then from inside, it's the thalamus, the hypothalamus, and the cingulate gyrus. Okay, so again, the limbic system seems to come around the brainstem and over the top. And so it's got lots over the top. So it's got the thalamus over the top, it's got the hypothalamus, it's got the cingulate cortex, of course, plus that corpus callosum, and then around it, it's got the hippocampus and amygdala. So it's just like hugged in there close. So for damage from blunt force trauma, for example, these other outer structures are going to get damaged before that brainstem. The limbic system, the role of the limbic system as a unit is maintenance of life. So where the brainstem is kind of like the definition of life. If those are all functioning, you are alive. With the limbic system, it's what helps continue your life. And so both the amygdala and hippocampus relate to memory. And if you think about the hippocampus deals with content memory, so memory you can talk about. It deals with spatial memory for spatial orientation. So if you're sitting right here at your house, wherever you're sitting, and if I were to ask you, where's Ellensburg from where you are? You could kind of sit, even though like in my office here there are no windows, but I can sit here and think, okay, how am I oriented? So I'm oriented like this, and so I know that Ellensburg is that way. And then I can go outside and check. But that feeling that you get, like how am I situated and where is it, that's all your hippocampus helping you. The hippocampus also plays a role in memory consolidation. And what that means is it's what allows information to be compacted or associated. So in class, for example, you have the experience of the people who sit around you and what they look like. You've got the questions that get asked during class. You've got my answers during class. You've got the things that are up on the board during class, your notes that you take or don't take during class. You've got, I don't know if I said what I write on the board, what I put on the overhead. You've got the sounds of sometimes the lawnmower outside. You've got all these different things. And the hippocampus helps take all of those together and consolidate them and make them into kind of like a memory unit. So that if you in maybe 2 months when this quarter's over and you've moved on and left me behind crying in my office, then when you think about my class, you'll pull back information that has been now associated with that experience. That's the hippocampus. And that also happens a lot during sleep, so it doesn't necessarily happen while you're awake, but when you're sleeping and your brain's kind of wrapping up what it's supposed to be doing. Okay, excuse me. So the amygdala also plays a role in memory, and you're going to find out that I already mentioned the cerebellum plays a role in memory. Now the hippocampus, the amygdala, you're going to hear cingulate cortex or cingulate gyrus plays a role in memory, prefrontal cortex. So just kind of keep track and notice where you get that redundancy. So the amygdala, the new research on the amygdala suggests that it's essentially a threat assessment. It plays a threat assessment role. So memory for what could be threatening. Seems to have two pathways, one that goes through the thalamus, and actually we'll hear from the amygdala. My details might be a little off, but there's two pathways, one that allows you to talk about the threat and the other one that gets you to react faster to the threat and then talk about it later, kind of like a spinal reflex in a way. So it deals with primarily like rage and aggression, that kind of a thing. So it's sort of assessing the world almost like a sensory filter, but in this case it's a more specific sensory filter looking for threat. Okay. The hypothalamus, which is that structure that comes over the top and it's really hard to see, but it's right down. It's not any, you can't really even see it, but it's just this lower part, kind of that triangular part in front of and below the thalamus. The hypothalamus always works together with the pituitary gland, and it regulates kind of what you would think of as homeostasis. So it regulates hunger, thirst, thermoregulation, and thermo is heat, regulate is control. So it's what helps us keep our body temperature at roughly 98.6. Regulates sexual urges, so hormones, thirst, hunger, thermoregulation. Why do I think there's another one? Anyway, that kind of stuff. So that's what it does. And you can see obviously why those things contribute to let me get my, there we go, contribute to maintenance of life. You got to eat to survive and drink water to survive and so forth. The thalamus, I want to show you the thalamus like in its naked form. because the thalamus, if you look at a mid-sagittal section like this blue is the thalamus, and that just looks boring and it looks pretty. Who wants to be a thalamus if that's what you look like? But if you take off the cerebral cortex so you can see the thalamus in its naked glory, these two big structures comprise a thalamus. Now that's impressive, doesn't it? It looks like an alien brain or something. But that's impressive. This right here that you see in that mid-sagittal section is simply the part where the two sections of the thalamus right here connect. So when information comes up, it comes up on the spinal cord, hits the medulla, it's going to cross over and go to the opposite side, and it's going to go up to the thalamus, and the thalamus's job is to route this information coming in to the part of the cortex where it's going to get processed. So information that comes in from the eyes, but actually the optic nerve enters at the midbrain right here. So information coming in from the optic nerve is going to come in here, and it's going to go up, and the thalamus is, when it hits the thalamus, it's going to end up going back to the occipital lobe to get processed. Information coming in from the skin is going to come in, it's going to come up, it's going to go over, and then it's going to get sent, sort of get routed as it goes to the thalamus, it's going to get routed up to the parietal lobe to get processed as touch. So the thalamus is kind of like an old style operator, and in the olden days, the operators had cables, and they would be like moving the cables around to get information from one place to another place. And that's kind of like what the thalamus is. It's kind of like a hub, and information comes into the hub, and then it gets shipped out to wherever it needs to go. So one thing to consider is that there's nothing active happening here. It's just that that's the location where those axons are getting, they end up routing to the right place. Okay. And then the last thing is the cingulate cortex, and I've got to put this back together. It always feels a little like a intelligence test, and I'm always a little concerned that I won't pass it. Here we go. One more. Okay. So now the last part of the limbic system is the cingulate cortex, and so now if we've got two hemispheres, and hemi means half, so we've got two halves of the brain. This is the left hemisphere. You're looking at me backwards, but this is the left hemisphere. This yellow is the cingulate gyrus. If when I get really close, you can see that there's a continuous, right here, that continuous separation, and that separation is called a sulcus, S-U-L-C-U-S, sulcus. So that's a continuous sulcus, and each gyrus, and a gyrus is the bump, each gyrus is separated from another gyrus by a sulcus. So the gyrus is the bump, and the sulcus is the dip. So we call this the cingulate gyrus. Sometimes you'll hear me say cingulate cortex, and what I'm referring to there is only the outer gray matter of that gyrus. So the gyrus is a bump. The gyrus is something that you could reach out and grab. So the cingulate gyrus, I can reach in and grab this like that. So that's the gyrus, the thing I'm grabbing. But only the outer layer, the gray matter of that gyrus, is the cortex. I tend to use them interchangeably, but they if you want to get nitpicky, they refer to slightly different things. So if you look at this cingulate gyrus, you can see that it has connections around the entire cerebral cortex. And so this part is right next to the frontal lobe. This part is right next to the motor cortex part of the frontal lobe. This is right next to the sensory motor, somatosensory cortex of the parietal lobe. This is connected right here. It's right next to the parietal lobe, and this back here is pretty darn close to the occipital lobe down here. So it has its fingers in everything. And so this is really challenging to study. But what folks have figured out so far, we seem to have more information about the anterior part of this structure, and it seems to play a role in impulse control, associating things, like associating the proper facial expression with the proper event. Like funerals are sad things, and so you would associate a sad face with a funeral and a happy face at a comedy sketch, and not vice versa usually. Impulse control as it relates to things like gambling. I went to school in Reno, and you would walk through some of the what do you call them? Gambling establishment, casinos. And sometimes we'd walk through early in the morning if we were going to go get a cheap breakfast or something. And there's people at those machines, even at 7 in the morning. And so those are folks who may, I don't know, not all of course, but who may have some issues with their cingulate cortex and gambling. It has to do with judging consequences, sort of values and consequences and risk analysis and that kind of thing. Plays a role in learning, plays a role in memory. So it's a challenge to understand specifically what damage would result in, but we do know that people with gambling addictions, drug addictions, schizophrenia to some extent, so that's not addiction but a different disorder, have cingulate cortices, it's a plural, that differ from the norm. And when we say normal in psychology or norm, it's typical, it's not a judgment of what's good, it's just what's typical. Okay. So I think I'm going to go ahead and stop there, and I'm going to try and get a couple more lectures done, but I probably won't get them done until Sunday. I'm still trying to grade papers. So I'll stop there and watch for email, and if I can get another 1 or 2 done, I will send out an announcement on email so that you could watch them on Sunday. In fact, you could watch them in that extra hour that you're going to gain. So instead of sleeping, you can watch my smiling face, give you more information. Okay, I will stop there, and I will see you on the flip side.